What up, everybody? Welcome to Friday, another day here at Fast Tracks at Electrical Code Academy. Welcome to Coffee Hour with Paul. Thanks for joining me today. We've got a great show today. We're going to be talking color coding and dispelling some of the myths that we see out there. Talking about unions and what you would see with, for example, NECA and other types of specifications that you might see out there, or even some localities who may require certain things. So if you've never come to the show before, we do this every day, Monday through Friday from 8 a.m. till 9. Sometimes I go a little over. Again, I'm long-winded as normal. But what we do is we talk the National Electrical Code and we talk electrical. And you can come and join us on our Fast Tracks Tube. It's free. Or you can join us on our YouTube channel. And then occasionally we will stream on other platforms as well, like LinkedIn or Facebook. But it's always a guarantee on YouTube and on our own platform at Fast Tracks Tube, electriciantube.com or fasttrackstv.com. But occasionally we share it on the other platforms as well. So thanks for joining me today. As always, let me know where you're from and let me know if you're a Fast Track student or if you've been in our program before, that type of thing. Here we go. We got Michael. Good morning, Michael. Thanks for joining me. Well, there's an old timer right there. Jesus calling Fast Track student, has been before. Welcome. Pyrex, good morning. Welcome. Thanks for joining me. Y'all let me know where you're from. TJI, familiar face in the morning. Thanks for joining me. Pie's right here in Virginia, right where I'm at. That's awesome. Thanks for joining. All right, guys. Thanks, everybody, for joining me. Again, I know it takes time out of your busy day, but we always can have a little bit of a coffee hour in the morning, talk code, talk about things that are on our mind. Maybe you're experiencing something on the job that you're just dreading to have to go to. Let me know. Maybe you have an issue with an employee. Maybe you have an idea of how you want to promote something. Share it with everybody. All those type of things. That's what we want to do. That's what we come here every morning in order to have our coffee and chat about the code. And I will throw in a little bit of code and talk about different topics. But again, this is driven by you. So again, make sure that you let us know what you want to talk about. All right, what do we got? Buenos dias. Buenos dias, Joe. Thanks for joining me. And they from Nebraska, Dave. Chilly, Nebraska. It's got to be cold in Nebraska. All right. Again, thank you for joining me. Keep them rolling, guys. I appreciate you coming in. Loved giving you shout outs and love seeing you here in the morning. Get your day started. It's Friday, dude. Week's almost over. Got to put in a little work today. Maybe it's payday for many of you. Maybe it's, if you're a contractor, it's really payday. You're going to hit that builder up and say, "It's time to pay." There we go. From southeastern Wisconsin, Alex. Thank you for joining me. Appreciate it. All right, let's talk about it today. Oh, before I get started, again, little merch. There you go. This is one of our latest mugs. It's available in black and white, but we have them in journeyman or master. Love having my coffee. 2 sizes available. This is the larger, I think 15 ounce, but there's a 12 as well. I got to get as much Java in me as I can. So I am a coffee freak. And for those that want some unique coffee, I am drinking my blend today. I forgot to bring it down here to the studio. But I am drinking our blend. It's a bit expensive. But again, I'm also a Dunkin' Donuts K-Cup kind of guy too. So, but anyway, if you've seen on our website, we do have our orange coffee. It's a bit expensive. So I don't expect many people to buy it. But it is a neat thing. Just the bright orange packaging is pretty cool. Anyway, let's get some coffee. And let's get in it today. Again, ask your questions. Feel free to ask your questions in the chat. I'll do my best to answer them. If not, I will direct you to paulabernathy.com to possibly be in a future episode. But if I can do my best, I will try to answer what I can answer. All right, we're going to start this journey. So first questions that typically come up that people will ask me is it required to have black, red, blue? Now, let's just talk from a general conversation point. Is it required to have black, red, blues, or black and reds, for example, for a 120-240 or a 120-208? Now, it may say that in your specifications. It may be what you've been taught in trade school. It may be what is required by NECA or some other IBEW. And that's been hammered in our head, and that's fine. That is a good way to identify the 12240 or 12208 circuits. It's a great way to identify it. The question that people have routinely is that a requirement, right? So it is a requirement if the specification you're working with requires it, okay? So if the engineer specifies it, and that's where I see it a lot, if the engineer specifies it, then it's a requirement. Not necessarily an NEC requirement, but it is a requirement for that specific project. Why? Because the engineer on record has stated that's what they want. Now, are they always right? No, but that's what they've stated they wanted. So we're going to follow it based on the engineering design because we don't want crap to fall back on us. Because you know how it is. If an engineer designs to do something and we do it differently, and we don't clear it with them on a lot of jobs. Now, we're not talking about those guys that you do your as-builts or you're basically left to engineer it yourself. I'm talking about those projects where they define what we do in a specification and we have to follow it. If something goes wrong, they are always looking, and I'm not picking on engineers, okay? I am one, not a PE, but I have a degree in engineering. They always look for a way to point a finger. And it's not mine. I didn't do it this way, or I didn't tell them to do this. And so we want to eliminate that. So if they say do something a certain way, we do it. But the black, red, blue scenario is not a requirement in the National Electrical Code. It's not. Okay, so I used to tell a story about this electrical contractor back when I was teaching continuing ed here in Virginia a lot. And I had a female contractor who loved to do things with lavenders and pinks and tans. And she just was different than everybody else. And so much so that sometimes we have the same people would come to the continuing ed. It got to be a thing. I don't know if any of you in Virginia are old enough to remember that I helped start that requirement in Virginia. So for about 2 years, I was the only one doing continuing ed in Virginia years ago. And I would travel to 4 corners of Virginia to teach these classes. And so I got to know everybody and see people regularly, and they knew each other. They were contractors in the area, right? And it would always be that one event I'd go to, and she was in Northern Virginia, the Manassas area where I would teach, right? And so, actually, I'm going to talk about that, Caleb. Actually, I'm going to bring that up. Glad you brought that up. And Pi, I'm also going to talk about that. Glad y'all are on the ball today in the chat. So that is awesome. I will share it on the screen, folks, the comments they made, but they are absolutely right. And it is why some of our industry has shifted a little bit. But back to my story real quick. So every time I'd go to these teaching these CEU classes, she would be there. And people would make a comment about, yeah, she does her colors different because they remember the conversation from the 3 years prior or whatnot or something. And basically, she said that she does things different. And lawyers would cringe some of the stuff she does. But it was brilliant. And I've always talked about it for years. She labels everything up. And some people will say, well, if you put too much identifiers on everything, your company or whatever, it makes it easy for lawyers to find you. And her response was, bring them on, because I do everything right. Now, that might sound cocky, conceited. The irony in that is not lost on me. But the fact of the matter is she was very confident. And so she would use colors that she stood out. She would actually put labels at the terminations on the installation. She would put these little labels that actually had her name and phone number. She would put them on the panels. If they were above the ceilings and she would hang labels at certain places on her cables in the ceilings with her name and everything. And she stood out. And she wasn't afraid of letting people know, this is who I am. These are what I do. These are the color systems that I use. And guys used to always say in there is, you can't do that. They've got to be black, red, blue, or they got to be black and red. And she was absolutely right. She did not have to be. Okay. So, what's up, Red Dog? Thanks for joining me out there in LA. Early again for you out there, but again, loyalty. There you go. Appreciate you joining me, getting up and getting your day started. So, as you can see, black, red, blue is not a requirement in the NEC. Now, let's jump to brown, orange, yellow. Is that a requirement in the NEC? Absolutely not. Now, there is rules in the NEC. Now, these are color coding systems that have been spread along by IBEW, NECA, apprenticeship programs, because you know what? Standardization is good. And people wonder, how come the NEC, I'm going to be honest with you, I serve on NEC code panels, and people ask, how come the NEC doesn't mandate something, okay, for those? We haven't gotten there yet, Caleb. We're getting there. We're getting there. But they mandate it and go, how come the NEC doesn't mandate black, red, blue, 12240, 12208? And how come it doesn't mandate brown, orange, yellow, orange for the high leg? It is a requirement from the NEC when you're using color coding. It's not required if it's not color coding, because so you can have numbers and not have any color at all, like use black, ICEA method 4, which is all black, and a high leg could be actually a number or say high leg. It doesn't have to be orange, but if you use colors, it does. But in general, black, red, blue, brown, orange, yellow, why doesn't the code stipulate it? And what we ask is, well, people have probably submitted that to the code panels for years. I can't attest to that because I didn't go looking for that. But for some reason, it never makes it, or if it's attempted, it just gets shot down, because as long as you identify and you make it clear where you have two different systems, then it really shouldn't matter. However, in some situations like maintenance, it can make a difference. Okay, so for example, Pa says it's tough on the maintenance guy. It can absolutely be tough on a maintenance guy, especially if there's two different systems in the building, right? Now, I can have a 12208 in the building, right? And I can have a 277-480 in the building. Two different systems in the building. Now, the code requires us to identify them separately so that there's a distinct difference between the two, okay? You have that rule in 210. You have that same rule in 215. So we're required to have that distinction. And you're supposed to mark those distinctions at places where they come together. Transformers, for example, distinction. In systems, identify systems out. Now, granted, if you have similar voltages in two different systems, then you can use the same color if the voltage stays the same, okay? But at the end of the day, we have to distinguish. And what you use is up to you, okay? So if you're going to choose to do colors as you're distinguishing, you're not going to do markings or numbers or labels, things like that distinguishes it. If you choose colors, and again, most people don't know this little history. The original colors for wire came from Encore Wire Corporation, believe it or not just because I'm intimate with Encore Wire. It actually came from a man named Mr. Rigo, and Mr. Rigo is the first one to introduce colors into our industry. Didn't patent it, didn't want any patent on it, didn't think about patents at the time. He's also the same guy that introduced the sheathing colors, like with non-metallic sheath cable. Again, Mr. Rigo. He was a pioneer in the industry. And then when you don't patent stuff, then what happens is everybody does it. And even if you patent something, everybody can still do it, because a patent is only as good as you're willing to defend it, right? Kind of like my patent on MCPCS. Everybody makes it now, but it's one of my patents. We, as a company, never defended it. And so we're like, we'll say it's good for the industry. And everybody wins, okay? And that's where you get the 0 to 10 volt application. And again, color coding has changed on that as well, right? Because it used to have the color coding inside of it that could be confusing for people, right? So it's one of those things that, we typically would use gray in those 0 to 10s for years. And all of a sudden now we're kind of moving away from it, and now it's purple and pink versus purple and gray, only because the gray confuses people. And personally, I didn't think it should confuse them because it's such a small conductor. I'm like, really? That doesn't go with any of the neutrals, okay? You should know this. But there's maintenance folks and different people that may not know this, and so it created a hazard. So most of the industry is taken over and decided to change our color coding when it comes to things like the MCPCS, which you might be familiar with, was like Southwire makes a Duo, and Encore makes a, or AFC makes a luminary cable, that type of thing. Okay, and we at ours, we make it MC LED. Okay, all of that stuff that has the 0 to 10 in it. So signaling and control is in the same cable assembly. We're all exploiting 725.136i, and we're all doing it. But the color coding could be confusing in that, even though it's in its separate cable, it shouldn't be. People get confused. So the industry has changed when it comes to certain color codes and things like that. But when it comes to power, black, red, blue, brown, orange, yellow, whatever you want. Now, how that can be confusing for people is if you don't let people know and they go into a building and they see color coding systems or they see coloring, identifying voltage and all that they're not familiar with, then that can create a serious hazard. But let's talk about the colors that are required, okay? So we're going to talk about, and there's no better place to start than with the grounded conductor, okay? No better place to start that journey of what is required to be color coded, because we've already made it clear that you can choose. So if you want to use pink, lavender, and tan for your 12240, go for it. If you want to use that for your 27740, go for it. You just have to be consistent and you have to mark it so that people know what voltage systems we're dealing with. And we'll look at that a little bit detailed in a second, but let's go and let's identify what has to have a color. Okay, or has to be identified with the type of color. So let's start with that. Now, the exception to this rule for grounded conductors is example on service entrance cable, where it would be helical and it's serving a duty as being the grounded conductor. Then it's not color coded because it is bare and it's inside of a cable assembly, right? Okay, so or you could have a service drop where it is bare messenger supported with the steel core. It's ACSR, for example, aluminum conductor with a steel reinforced core. That is a support that typically will be bare. But once we get in and we get past the service, then most time we're going to have insulated grounded conductors. Okay, most part, and we have color coding. Again, the exception to that rule is cable assemblies that allow you to have the bare in it, like an SEU, right? Product, that type of thing. Okay. All right. So let's go down here real quick. So here we've got Article 200. Okay. And let's just go and get down to our color requirements here. Okay. Let's start right here. Okay. So we're talking about the grounded conductor, which is for all intents and purposes for us, the neutral. Not the neutral on a corner grounded delta. That is just a grounded conductor. It's not a neutral. But in most systems that we have where, for example, a Y system or a 120, 120, 120 in the center tap, okay, all of them are 120 to the center. That's a true neutral. But it is also considered a grounded conductor because it is intentionally connected to Earth. So that's why we call it a grounded conductor. Okay, it's our reference point. So at the end of the day, talking about grounded conductors, which is a much broader term than just neutrals, okay? Remember, not all grounded conductors are neutrals, but all neutral conductors are what? Grounded, okay? Okay, so let's look at the color requirements. So if it's 6 and smaller, okay, then it has to be, again, we're talking grounded conductor, it has to be continuous white outer finish, okay? The whole way. So it's extruded. So we're going to extrude a white insulation over it, okay? Now, there is an occasion where you'll have a white nylon even extruded over a conductor, and that's fine as well. That's part of the construction of the conductor, okay? So the point is it's a continuous white outer finish, okay? Next is you have an option for a continuous gray outer finish. Okay, so is gray outer finish only reserved for 277 applications? Absolutely not. But if I have a 120 240 volt system, obviously 120 being a neutral is involved, or grounded conductor as well involved, and then I have a 27740, a neutral is involved as well on the 277 side, right? But we have to differentiate what goes with the 120 volt system and what goes with the 277 volt system. So you would have a white for the grounded conductor in the 120 system, and you would use the gray distinguishing the neutral application for the 277. Okay, two different systems. Now, we won't get into all of these, okay, because it's just different examples where we get into. You can pretty much read that, but again, I'll go with the four main ones that we worry about. This is the third one right here, is you can also have 3 continuous white or gray stripes on along the conductor's entire length on other than green insulation. So I can have black with stripes, 3 white stripes or 3 gray stripes. I could have red, 3 white or 3 gray stripes, okay? So I have these different options, okay, for identifying the grounded conductor, okay? So usually they run this 120 degrees apart, and they'll run along the entire conductor, okay? That is possible to be on, again, and that usually comes when you get bigger conductors, that we're identifying it that way, okay? And then, of course, you have conductors with white or gray insulation and colored tracer threads in the braid identifying the source of manufacture. Okay, so you can have braided, or you can have conductors with white or gray insulation and have tracer threads in it, okay, in the braid to identify it as well. So we have these different options. And, of course, there's a couple other ones that you can have as well, right? Not as common for all of these. All right. Now, what about in sizes 4 and larger? Because here it makes it pretty clear that the majority of what we do, we're going to see something, especially when we're dealing with 14, 12, 10, things like that, 8, 6. We're typically going to see the full colors, right? But when you get to sizes 4 and larger, you are given some allowances, okay? And this is where it kills a lot of people, because I can tell you how many times I have been called out and I see things for like hot tubs. And you have hot tubs and they're installing the hot tub and it ends up getting 6 gauge, right? Which 6 and smaller, and they end up using black for the grounded conductor and they put white tape around the end. And they wonder, well, why do I fail the inspection? Well, the reason they fail the inspection is because, in this case, it needs to be continuous white or continuous gray, 6 and smaller. You do not have the option. Now, I get it. People tell me all the time, that's the problem with code. That's a problem with somebody like me who's just got to spout off code, and then I get the backlash from people that say, well, you've never done it then. You've never been an electrician in the field. Whatever. Look, I'm here to teach you code. It's none of your business what I've done in the field. It's none of your business what years I've put in the trade. I'm here to teach code. That's it. You can still do what you want to do. If you can get it past an inspector, you do you, boo, is what I always say. Reality is, in those applications where it's 6, then that 6 is supposed to be continuous white or continuous gray, if we're talking about the grounded neutral conductor. Okay? It's just what it is, like it or not. It might be what you have on the truck, and you might be already running 6 for the hots, and you might be thinking, well, come on, Paul, what does it really matter? Okay, well, I'm not condoning this, but I do know people who have heat shrink of white, and they heat shrink each end of the white, so there's really no way to, but anyway, I'm not going to elaborate anymore on that little tricks that people do. I don't want to condone it. All right, so 4 and larger, okay? So insulated grounded conductors 4 and larger shall be, it's not, this is a mandatory rule. Shall be is mandatory. It's not shall be permitted. It shall be identified by one of the following means. Okay, well, you still have your white continuous finish. You have your gray continuous finish. You still have the 3 continuous white or gray stripes along the entire length on other than green, so you can't use green. Any other color you want, just can't use green. And then at the time of installation, so here is the one that we get away with marking at installation, Okay, 4 and larger, the grounded conductor. It says at the time of installation. So you're pulling it in, you're terminating it, okay, everything. It says at the time of installation to be identified by a distinctive white or gray marking at its termination. Okay, so this brings me to an interesting another topic. And again, it's installer specific if that's what you want to do. But I see a lot of people that literally will wrap that entire conductor with white tape all the way down as it comes out of the raceway or whatever it's in. I've seen them do that. You don't have to do that. Notice it says identified by distinctive white or gray marking at its termination, not the entire conductor. Now, if that's what you want to do and you want to wrap it all the way around and make it, that's fine. I'm just saying you're not required to. So realistically, all you would have to do is put it at the termination. So come down from the termination about an inch, whatever you want. Okay, but again, there's a fine line when you do it further down and it's not at the termination that you end up causing somebody to question it. Don't make it that difficult for your inspector. Don't create problems. Just put it right there as close as practical to the actual termination. Once you get on the installation, wrap around it. Now, what does the code say about it? You put the tape on there. I see a lot of people put tape on it, just put it on the side of it. I'm like, that's not what the code says. The code also goes on and says that this marking shall encircle the conductor's insulation. Okay. So it needs to, at that termination, it needs to encircle. Okay. That termination to be made very clear what that termination is all about. Okay. Absolutely. So what do we got here? Justin, good morning from Southern Alabama. Do you have a suggestion for a brand of clamp-on style ground-resistant tester? Thank you for the years. You're most welcome. I do not. I can tell you that there is different brands, all of the brands out there that as long as you get one that's listed and one that's been, that has all the marks, UL marks, it has the safety, CAT safety marks on it, they're all going to be fine. I really don't have a brand. They're made by Fluke and they're all name brands. That type of thing. But when it comes to the ground resistant meters, there's I can't remember the name of the company that makes good one. Hold on for a second. I'll find it real quick for you. Hold on real quick. I'll find you the one that hold on here. Let me find this one that I actually like hold on here. And it's not cheap, but I'm trying to find it real quick. Fluke makes a great one, but here it is. Hold on. Let's see here. Let me find it. Okay. I'm going to share the screen, see if it works. Okay. So this one is one that is made, and it's made by AEMC. I found these. I have some friends that have tried these, and it's fairly easy to use and it's fairly accurate. Pricing wise, I couldn't tell you. Here's list price is $1,600. I can tell you I've seen the ones that are reliable that I've seen run anywhere between $1,100 and $1,800. Now, you know what people are going to, I can tell you right now, the thing about those is, hold on for a second. Let me see if I can't get my screen a little bit easier for you folks to see. I want to tell you about those is that the only reason that somebody would use one of those is if they don't want to pound rods, because that's the only requirement for the ground resistance is for rods, piper plates, where you don't have to. So you two rods, if you can't prove that it's 25 ohms or less, then you install two, and if you can prove it, you can drop down to one. It's much cheaper to buy the wire, 6 gauge copper, and it's much cheaper to buy the ground rod and just have the helper pound it. So again, now if you're doing a lot of cell towers, you're doing a lot of engineering where they're really hyper focused on getting the earth resistance down really, really low because of the nature of the equipment you're working on, then I'd see the investment, obviously, because you got to prove to them that it's at a certain value. If it's just for residential applications, I can tell you I don't know that I necessarily recommend people investing in those or even the 3-point fall potential type of thing. I'm sure y'all seen those. Those are these. I'll share this as well. Hold on here. Let me show you these. I've seen these as well, ground resistance meters. The problem with these here is that you have to have quite a bit of ground area to work with, you know, and they make these, and these are cheaper. For example, this one, I think there's another one right here of resistance. They make a bunch of them, right? But this one, let's see here. It doesn't say what the price is on this one here. But they're typically, these kind that have the probes are typically much cheaper. But again, at the end of the day, if you're only doing it to not have to drive rods or extra, you know, more than one rod, pipe, or plate, it's really not worth it. I would just hammer one in and be done with it. That's my personal belief on it. Now, if you just want one and you're at the end of the year, right? It's tax write-off end of the year for businesses, right? Well, if that's the case, then get you one. But look to spend between $1,100 to $1,800 for a good one, that type of thing. And once you get up to about that price, they're all pretty much the same, okay? That type of thing. You get into the flukes and the fleers and all those kind of, then you're actually now paying more because of the name. And I don't necessarily buy into the names, that type of thing. So that's why I steer more towards things like AEMC, a well-known manufacturer, have pretty decent customer support, and they are, you know, not that big of a name brand, but pretty consistent with their products. Okay, makes sense. Let's see here. Savin, good morning, New Jersey. Thanks for joining me. Anyway, I hope that helped you out, Justin, as well on that. Okay, let's look back here. So let's get back to our topic here real quick. So, all right, so at the time of installation, you're able to do it. Just make sure you wrap it. You don't need to go all the way. You don't need to wrap the whole thing, just at the termination. That's all you need to do. Okay, so that is our grounded conductor. Those colors are required, right? That scenario. All right. Now, next, let's talk about, let's see here. Let's see if I want to give any more here. Let's go down to branch circuits really quickly. And I want to talk about this one here. Bear with me while I try to pull it up here. Okay. All right. So we're going to get into, oops, hold on here. Let me see where it is here. Hold on for a second. I got a freaking dude, what are you doing? I want to jump on it and it keeps jumping back. I'm gonna have to scroll because it just wants to keep jumping back. Daggone it. Why are you jumping on me? God. Hold on. Oops. I don't know if y'all can see it on my end. It's stuttering. Hold on, I'm having technical difficulties here this morning. All right, while I'm trying to get this thing sorts. Okay, hold on. Let me come back here while I try to get this freaking thing sorted. I'm going to refresh that screen. Okay, Justin, good deal. Glad we could get that one straight for you. What in the world is? Hold on here. Hold on here. Let me reboot this thing. Dirk it. I'm trying to reboot it real quick. If you've got any questions, please let them know in the comments while I try to reboot this thing here. Hold on, I gotta bear with me. Let me reboot. God. Not rebooting y'all. Y'all are good. You're not gonna lose anything. I'm just trying to trying to reboot this thing here. So, okay. All right. Hold on. Let me see if I've got it. Yeah. Okay. It seems to be not jumping. Are y'all having trouble too with Link? Red, what'd you say? Acting up? Yeah, it was jumping today, but it looks like it stopped. I reloaded it. So let me share it now and let's see. Let me see if I got it now. All right. Okay. It's not jumping. It's letting me move it. So we're okay. All right. So let's get real quick. I want to talk. Okay. All right, so now what we want to talk about is, okay, we pretty much covered the grounded. So now let's talk about those ungrounded conductors. Now, when you have a branch circuit, for example, and you have more than one nominal voltage system in a building, like we talked about it, where you have a 120, 240, and let's say in the same building you have a transformer and you're getting 277, 480, or vice versa. Maybe you have 277, 480, you're dropping it down to 120, 208, or whatever you're doing in your building. You got multiple voltages in the building. All right, so we're kind of understood that the colors can be whatever we want them to be. And I see your question, David. I will get to it in here in a second. So what are we doing? Well, when you have branch circuits supplied from more than one nominal voltage system, it says the premise wiring system has branch circuits supplied from more than one nominal voltage system. Okay, so I have a building that have multiple branch circuits supplying different loads within this building from multiple different types of systems. Okay. It says each ungrounded conductor of a branch circuit shall be identified by phase or line and by nominal voltage system at all terminations, connections, and splice points in accordance with 210.5 C1A, that's just right here, and C1B, that's an and. Okay, so I have to make sure we identify both of these. Okay, so the different systems. Now, here's what was changed in the previous cycle. It says different systems within the same premise that have the same nominal voltage shall be permitted to use the same identification. So what that means is if I have a 120 240 and a 120 208 in a building, whatever I use to identify the 120, I can use that same color scheme or that same identification for the 120, whether it's a 120 240 or a 120 208. So the 120 can be taken care of with one. It's the 240, it's the 208 that has to be distinctly different. And we have to mark that where? We have to identify that all terminations, connections, and splice points so that anybody going up to it and working in it understand that I potentially have two different voltages here from two different systems. So we have to identify that. And so that's where color coding comes into play, and that's why we typically will color code. But that's not the only way. I mean, we can do numbering systems as long as that nomenclature is on at the termination, at the connection, and at the splice points. So in your panels, that's where you'd make terminations. Okay, I need to know if I'm going to be dealing with multiple voltage systems in this building, and I need to know at this panel what systems colors are coming from this panel. Right, black, red, blue. This panel. And so that if I see a common location where I potentially could have different voltages coming together or different systems coming together, that I know at that point what I'm dealing with. Okay, those are the 120 volt, the 120, 240 volt. Those are 277, 480, or 120, 208. That's the whole purpose, and we're required to do that. Okay, so when it says in accordance, now I will show you an exception, okay, but we kind of get a good idea of our identification requirements. That's why we have the different colors. That's why we have the different identification. So what do we have to do? Well, we have to have a means of identification. The means of identification shall be permitted to be by separate color coding. We use colors. We buy wire today with colors on it. Marking tape, tagging, or other approved means. What the heck does other approved means? What does that mean? Well, that means that your AHJ could come up with a clever idea that's okay, and they're okay with it. They're like, I'm okay with it. They're fine. They're the ones that have to approve it. So that's what approved means. AHJ is okay with it. Most of the people don't let it get that far. They're like, look, I'm going to either color code it, or I'm going to use marking tape with a numbering system and have that nomenclature on the panel, or at all splice points and connection points, or they'll have some type of tagging on it. Again, one of the electricians that I used to know when they were doing this actually put little flags. They were like little flags, and it had the writing on the flags. I don't know if they had a labeler. I don't know what they had, but they had these little flags, and each little flag had on it the voltage. It was cool. But he, even when he did color coding, he liked to put the little flags on it. Okay, that type of thing. But that would be an example where that would be like a tagging. And again, the HJ still has to be okay with that. But again, you have a strong argument to say, look, it's a tag, but you can always fall back on the other approved means. The HJ can say, I'm okay with it. that type of thing. But that's what approved means. Okay, so much as people hate that, that is what it means. All right, now, other thing, it says posting of identification means. It says the method used for conductors originating within each branch circuit panel board or similar branch circuit distribution equipment shall be documented in a manner that is readily available or shall be permanently posted at each panel circuit panel board or similar branch circuit distribution equipment. The labels shall be of sufficient durability to withstand the environment involved and shall not be handwritten. So it's got to be typed up. It's got to be, now notice it says or shall be permanently posted, but it says in a manner that's readily available. All right, so this could be a massive industrial complex, and they're not going to label everything, and it's maintenance crew that are working on it, for example, right? So they may have beside it, may have a binder, may have something posted. It's in an envelope, maybe a folder. They may have a maintenance room that you go to, and they have a protocol, and it may be something on the panel that says, go to get the binder for this panel before opening and working in it. They may have their own protocol, okay? So if that's the case, it has to be readily available for those workers. Or, and that's the power of the or here. You can have that, or you permanently post it at each branch circuit panel board so that anybody that wants to know what the systems are in this structure, they can look right at it. And it's got to be rated for the environment. It can't be just an inkjet and you put it in an area where it's going to get wet or come off. It needs to be in a way that it is going to be permanent and be there for future people to be able to come to, okay? Now, let's look at the exception. There is an exception, because why do we have an exception? Oh, let me tell you. You will come in and add new circuits in a building, right? And you'll get inspections. I remember back in Virginia, there's a place that used to make, I don't know if all of you have ever familiar with Duke's Mayonnaise. It's the Sours company. They make spices, all kinds of spices, but they used to do inspections out there in their facility. And I was a supervisor, but I always loved to go out and do their inspections. Why? Because you know what? Now that it's been 10, 11 years, I'll say it. No, it's been more than that. It's been 15 years. Miraculously, always a box of spices ended up on my truck, the inspection truck. I know what y'all are saying. I got bought. No, they were ones that were going to throw away, and I'd already had clearance from my building official. They were packaging was messed up or something was screwed up, right? And I knew the guy personally. And I was still tough as anybody, but he was always like, we're going to throw these things away. And so I got clearance from our city manager and clearance from the building official. I said, dude, can I give these, if they want to give them away, if they're going to throw them away, can I get them and give them to the inspectors or give them to other people? And we had to check with the attorney for the rules and all this kind of stuff. And they were like, dude, if they're going to throw them away, right? And if you can testify or do an affidavit saying they wouldn't in no way change your opinion of the inspection, and they didn't because I failed them many times, they would just miraculously appear on the truck, and we would give them to the inspectors. But there's only one thing that they had that I liked, and every now and then I grab one. If it was in the pack, they'd just throw them. And, it could have labels that were screwed up. It could have containers that were only half filled because the machine didn't fill it. It was just always misfits. They were going to be thrown away. And we used to also give quite a few of those to there's a shelter that was down there. And at any rate, there was one that was called 7 blends of pepper. And routinely they would be only 3/4 full or something was wrong with it, but I couldn't help it. I had to have that 7 blend. Okay. So I'm going to sell out. But anyway, the point was that building constantly got new inspections, and it was existing, and it had a lot of circuits that were already in there. So you're adding new. There's no way that I'm going to have somebody go in there, and if the new system, they had a transformer or something like that, I'm not going to have them go and try to hunt down all of the old stuff that's existing in order to accommodate the new stuff that's coming in. So you had to have an exception to allow for that. So let's look at the exception. So here's the exception. It says, now remember, you have to mark that if you got 2 different systems, branch circuits in the building, and again, we won't go look at the feeder, same concept for the feeder, same deal. If you have multiples in there, then you have to identify them. But the exception is here. It says in existing installations where a voltage system already exists, okay, and a different voltage system is being added, okay, so already in place, been there for 20 years, 30 years, but now they add a transformer and they're bringing in another system, which constitutes two different systems in a building. It says it shall be permissible to mark only the new system voltage. So all of the new stuff has to be done, but the poor electrician doesn't have to go hunting down. David, you're absolutely right. I did use that on my briskets when I had my smoker, my Rectech smoker. I loved that seasoning on briskets. Anyway, I'm so easily distracted, but that's so true, David. All right, so that allows the electrician to not have to go through and do everything that's existing because they don't know everything in there, but they know what they put in. Now, it does tell us that the existing unidentified systems shall not be required to be identified at each termination, connection, and splice point in accordance with 210.5C1A and C1B, because it would be nearly impossible to do that, and it's too much of an onerous task for me to ask you, because you know how this is, guys. You're the electrician, you're coming in, you're there to do the new work. Be damned if I want to have somebody or some inspector tell me I got to go hunting through all these old stuff to make sure I change identifications, and we don't know what the hell they used, okay? So I'm not doing that. However, there is a requirement. It says, labeling shall be required at each voltage system distribution equipment to identify that only one voltage system has been marked for the new systems. So in those panels, you're going to mark that only one system, that label, only one system, okay, in this building, because you're putting in the new one and there's old existing, okay? So it says labeling shall be required for each voltage system distribution panel, each, all of them, not just the new ones, all of them, to identify that only one voltage system has been marked for new systems. The new system labels shall include the words other unidentified systems exist on the premise. So the old systems get the labels telling you what? That there are what? All systems have not been marked, only new systems have been marked, and all of the new system labels have to include the language other unidentified systems exist on the premise, okay? And this isn't a good example. I like the link, sometimes gives examples. Here is the one panel, okay? So this one is the 480, 277. So here you see their color coding is brown, orange, yellow, gray, okay? And the means of identification of ungrounded circuit conductors are posted here, right? And then this one down here, it's this one's a 208-120, and it says means of identification of ungrounded branch circuit conductors permanently posted here. This happened to be phenolic panels, by the way, okay? And this is what's identifying the 208-120. And to see the color coding system is different. This is brown, black, red, blue, and white. So you have to put these markings, okay? And of course, the exception we just talked about, and it allows you to say, dude, I'm not going back through there and do every other system in this building. Why? I'm not doing it, right? Okay, I'm stubborn like that. I ain't doing it, okay? So that's what you get for that, okay? All right, so hopefully that explains that. Hold on here. Let me refresh this because I saw it start to blink a little bit, and that's not going to happen for me. So let's go back here. Okay. All right. We're good. Now, somebody mentioned earlier, let me answer David's question here, but somebody mentioned earlier about the high leg, stinger leg. This is a situation where you have a delta high leg, 120, 240, but the high leg is going to be 208. In that scenario, as we have marking requirements, and that's a general installation. We want to go down here to high leg marking requirements. So here is an example where I'm trying to see if I can get it to show up without squishing the screen. There we go. That's a little bit better. Okay, so here is our high leg marking requirement. Okay, on a 4-wire delta connected system where the midpoint of one phase is grounded intentionally, Only the conductor or bus bar having the higher phase voltage to ground shall be durably and permanently marked by an outer finish that is orange in color. And here's where people get lost right here. Or they think orange always has to be the high leg. Or by other effective means. Other effective means. It didn't say other approved means. It didn't say it has to be something that the AHJ goes, I'm okay. It's other effective. So whatever you want to put on it, whether you want to put a heat shrink on it that says high leg, bastard leg, red leg, whatever you want to put on it, the color coding only requires it to be orange if it's a high leg, and you're going to use a color as an identifier for that, okay? If you want to use some other effective means, that is okay. Code allows you to do that. You want to put a label on it, a tag on it, whatever effectively makes it stand out that it is the high leg, okay? Okay, with me? Makes sense? All right, now, it says such identification shall be placed at each point on the system where a connection is made if the grounded conductor is also present. So anywhere in the system, junction boxes, equipment, if that high leg is present, then it needs to stand out. It needs to be marked, okay? So anywhere in the system. And this is an example right here of them showing what it is. So here's your, again, you saw me say it's a 12240 delta, but you have, in this case, mid windings, and you have the connection made here. So this is your typical A to C phase that we're going to get right here is where they're going to tap midpoint. But here you see the B. So from here to here, it vectorially creates the 208. From here, okay? And so you see here B to here, 208, right? That's that B leg, okay? And so that is going to be identified. If you're going to use color, use orange. If you want some other effective means, that's fine. And the reason for this is sometimes there are still people out there in large commercial applications that use black only. Speaking of the color coding, I think it's interesting to look at the color coding. And let's see here. Let me see if I can pull this up real quick. Let's see here. I'm trying to find it, and it acted like it didn't want to pull it up for me. There we go. Let me share this real quick. So this is a color coding for you that aren't familiar with color codings. This is kind of standardized color codings. So this is what we call the ICEA method 1, and it's very typical in your MC cables and things like that where the color coding, and it's pretty standard. Conductor 1 is black, conductor 2 is red, conductor 3 is blue, conductor 4 is orange, conductor 5 is yellow, conductor 6 is brown, and when you get up to 7, it is red, but it has a black stripe. 8 conductors, that type of thing. And then, of course, we have the very common method 4. And the method 4 is all black. So when you're identifying a high leg and everything is black, and maybe it's cheaper for you to buy all black, you don't want to pay the extra for the color. Again, it makes you have to identify things more, and you have to use identification tape or whatever. So it's a labor intensive, but let's say you do go with black. In this case, you can put orange tape on the high leg, or if you're going to just go with black, you can number each one of the legs and make sure that you keep that posted. But you could also identify that high leg with a label or a flag or a tag or whatever that's effectively lets people know that that's a high leg, okay? So there you go. Might have known that, or you might not have known that, okay? So that's your color schemes. Other than that, there's really no other color requirements in the National Electrical Code that we have to worry about. Now, we do have a question here that David asked. I see these examples all the time. They taped a 6 or 8 and taped the whole wire white. Always try to tell people that it is not necessary to tape that much. They always say, I thought it was at least 6 inches, etc. And they never like having to change out the wire when 6 wire are smaller. Yeah, so that's a good one there, because at the end of the day, when we're doing the identification, right, there isn't a size requirement for the ungrounded. okay, the hots, okay, that scenario. You can get it whatever. You can get it all black and put colored tape on it, whatever you want. There is no size requirement. It's, people, you really only have to identify it at the termination. To be honest, in any case, you don't have to wrap the whole thing in red or black or blue. There's nothing that says it has to be at least 6 inches or whatnot. Now, when it comes to the white, and where I see it the most is the guys that install things like hot tubs and whatnot, and they have the 6 or the 8 already on their truck, and they want it to be the grounded conductor, and they end up wrapping it, and inspector comes up and says, no, that's not going to work. And they're like, dude, it's copper. Copper's copper, right? I mean, that's what they say, right? Copper's copper. What does it matter, Paul? You're being a nitwit with it. Well, at the end of the day, code is code. And the real thing about it, and I hate to say this, the real thing that I tell electricians is the reason you do a lot of this stuff in the code, okay, you ready for this? The reason you do a lot of stuff per code and you don't cut the corners is because you become a target. And as an expert witness in cases, I can tell you that we go looking for the mistake that the electrician makes. I'm sorry, I have to tell you that. We do. And whether or not that tape caused somebody to get electrocuted, let's say in a water heater, okay? I mean, not a water heater, excuse me, in a, let's talk about water heater re-identification. Do you want to talk about that? Y'all got time? Let me know if y'all want to talk about why we re-identify in a tape and why we can re-identify conductors even smaller in a cable. I got to talk about that, but let me finish my story. The reason that we follow the code is because what can happen is that people get hurt, and when we get called in, we're looking for whatever we can start pinning the chain of neglect. And if it's an electrician that did something improperly, sadly, as a consultant, as an expert witness, as somebody that's being paid, we're going after you either way, okay? All right, guys are leaving. Don't leave yet. I forgot I got to talk about one more thing. I just thought about it, okay? All right, so that was our re-identifying the white. Now, lastly, let's talk about when you can re-identify a white wire as a hot. When can you do that? Okay, because we talked about identifying ungrounded conductors. We talked about identifying the white conductor or the grounded conductor, white or gray. But when can we, for example, take a black wire, right? Or no, take a white wire and make it black or red. When can we do that? All right. Well, here you see 200.7. You don't see it because I'm not sharing it. Here we see 200.7. And this says use of insulation of white or gray. So I want to use the color white or gray, okay? Or the one with 3 continuous white or gray stripes. I want to use them. So here's what the code says. It says the following shall used only for the grounded conductor unless otherwise permitted in 200.7 B and C. Okay, so a conductor with a white or continuous gray covering can only be used as a white or continuous gray covering. B, number 2 says a conductor with 3 continuous white or gray stripes on other than green can only be used as what? A grounded circuit conductor. All right. And then lastly, it says a marking of white or gray color at the termination can only be used as what? A grounded conductor. Okay. We saw those rules that let us do that. If it's 4 and larger, we can identify it at the termination. We saw all that. Well, this says the following can only be used as a grounded conductor, okay, unless otherwise permitted in 200.7B and C. Well, now, we come down here to B. B is for those circuits of less than 50 volts, okay? We're not going to talk about those. We're going to talk about the ones that me and you see, or me not much anymore. You see, I get calls about it all the time. It's for circuits that are 50 volts or more. So it says the use of insulation that is white or gray or that has 3 continuous white or gray stripes for other than grounded conductor for circuits of 50 volts or more shall be permitted only as the following. So I have people all the time ask me, Paul, can I take a white conductor and re-identify it in a raceway? Absolutely not. And they say, well, it doesn't say that in the code. Look, it doesn't have to, because it's telling you right here, the only applicable rules that allow you to use the white conductor or gray conductor is anything other than a grounded conductor. Right here. Black and white, right? So let's look at it. All right. So this one right here, very first one, the most common used is if a part of a cable assembly that has the insulation permanently re-identified to indicate its use as a ungrounded conductor by marking tape. Now, notice that it says right here, cable assembly. So all you need to know for that part, okay? Can I use tape? Absolutely. Can I use painting? Absolutely you can, as long as the paint is not detrimental to the insulation. Oil-based paints can have problems with some types of insulation, so be very careful. Water-based typically doesn't have an issue, right? Okay, it says, or other effective means. Again, that is very broad. That could be labels, that could be the flags, little tags, whatever, okay? Other effective means at its termination and at each location where the conductor is visible and accessible. So anything that's got a panel cover, you can get to it, things like that. So water heaters. We typically run a 10-2 within a ground to a water heater. Typical non-metallic sheath cable, people refer to as Romex. They'll run that to that, and when they get there, they'll take the white wire and they'll wrap it in tape because it says here that you can do that. It's a cable assembly. Would not work if it is a raceway, okay? So, interesting point, and I'll answer your questions because, again, I say it's coffee hour, but as long as y'all are still here, I'll continue on. If you get tired of me, you can always leave. I get it. I'm not appealing to most people. Steven 120 posted a picture a couple of days ago about transitioning NM cable over into a raceway that went down to a water heater. I had no problem with the installation with that. The only potential problem he has is at the moment that he transitioned over into that raceway, if he happened to strip those conductors out of the sheathing, which he didn't, he took it all the way in, he's okay. But there are still people out there that strip off the sheathing, and that would be in violation of the listing 719 for that cable, okay? But if he did, and some inspector walked in and they didn't, all they saw was this raceway, I mean, let's just say they looked in there, and now they saw a white conductor in there because it came out of what? NM cable, and they saw that it was re-identified, they could cite this for that. Now, by then, the inspector's probably going to say, wait a minute. You're not supposed to strip off that sheathing but what I'm hearing on TikTok is that people let you do it all the time, even though you're not supposed to. But that creates another issue because now those conductors are in a raceway and you can't re-identify the white in a raceway. You can in a cable. They say, well, it came from a cable, but it's not a cable anymore. You stripped it, okay? And you weren't supposed to do that, but that's the kind of the concept. What's up, Ronbo? Thanks for joining me. I'm glad you woke up today. I'm just saying. My boy from Tennessee. All right, just teasing you. All right, so anyway, so let's go on. Okay, so that's visible. Next, it says identification shall encircle the insulation. Again, don't have to wrap the entire conductor. All you do is encircle it. One wrap around, it's fine. And shall be color other than white, gray, or green. Well, obvious. So if it's a 10-2 cable, it has a black and a white. Obviously, I'm not going to wrap the white with a white. I'm not going to wrap it with a green because we have rules in 250.119 for identifying of the equipment ground, right? So I'm not going to do that. I'm not going to try to wrap a bear. That's an allowable scheme up in 250.119. So I'm not going to do that. And I'm not going to take the insulated conductor that is white and try to wrap it with green. No. Or gray. So in this case, if I'm going to be taking a white, I have to wrap it. I could black, red, blue, whatever. All right, other than white, gray, or green. Makes sense. Okay, now, it also goes on to say, if you happen to be using that white, for example, in a single pole, okay, maybe you're doing it as a switch leg going down to a switch and not back up to the light source, okay? You're going down. Maybe you're using a 2-wire and you're going to drop it down. Okay, so well, if you happen to be using it in a single pole, in a three-way or a four-way switch loop application, it says the re-identified conductor with white or gray insulation, okay? So we're taking, or 3 continuous white or gray stripes shall be used only for the supply to the switch. So going to the switch, you can re-identify that white, but you can't do it back to the return, you cannot, but not as a return conductor from the switch to the lighting outlet, going back. So it's got to be supplying, going down to the switches and over to the switches, but not back and up to the actual luminaire, okay, or the outlet, okay? So pretty clear. Allows me to re-identify only in those scenarios and only with a cable assembly. And those that say, well, it doesn't say raceway, it doesn't have to say raceway because it only allows you to do it, and it says right here, only permitted to do it when stated in 200.7 B and C. And in this case, since we're dealing mostly with 50 volts or more systems, here it says cable assembly only. Now, here's the other thing. There is no size requirement here, okay? So can I, whereas you saw the conductor re-identifying it, for example, you saw with the 200.6 rule, right, where I could take a black and make it a white and forward larger at the time of installation, you had size requirements. You don't have any size requirement here. So it can be, again, that's why we do it in 14, then we do it in 14.2, we do it in 12.2, 12.3, 14.3, 10.2s, all those type of things. Again, we see it it's done in MC cables at various sizes, that type of thing. So, and then of course the other is a flexible cord having 1 conductor identified by a white or gray outer finish, or 3 continuous white or gray stripes, or by any other means in accordance with 400.22 that is used for connecting an appliance or equipment in accordance with 400.10. This shall apply to flexible cord connected to outlets, whether or not the outlet is supplied by a circuit that has a grounded conductor. Okay. Now, illustration-wise, this is what we're talking about. I knew that there was a illustration, and y'all are more than familiar with this. This is what we deal with mainly right here. Okay. So here it's dropping it down. This is probably dropping down to a switch leg down, dropping down on the white, and they chose to use this as a hot conductor, bring it down, and they wrapped it in red. Don't have to wrap it all the way up, okay? You just put a loop wrap around it right here is fine. And then again, you see that the black is carrying it back up to the actual outlet, okay, the lighting outlet, okay? That's acceptable to do that, and that is a cable assembly. Dead giveaway is the bare equipment ground, okay? So I just wanted to make sure I covered that as far as re-identifications and all that kind of stuff as well before I left on the color coding concept, all right? All right, we went a little over today. Most of you stuck around. If you have any additional questions, I'm more than happy to take them. Oh, wait a minute, Red had something. I want to make sure, Red, I get your question here. For ambient temperature correction of 106 degrees Fahrenheit, the ampacity on an 8 AWG THN, I'm assuming you mean THWN-2, is 55 amps after correction. I get 47.85, and if protected at 50, GFCI overcurrent protection for SPA does all look good. Okay, let me try to piece together what you're saying here. So you've made an adjustment. Let's see here. So let's go to, you still got a 50 amp, I guess, overcurrent devices for the 50. Okay. So let's kind of walk you through it. Those that don't want to hang around, you're more than happy to bolt off. All right. So let's go here real quick. Okay. So we're here and you say it's an 8. Here's an 8 and it's good for 50 amps, right? So we have to protect conductors at their ampacity. If they do not correspond, we can go to the next standard size if they do not correspond. All right, we do have that rule in 240.4b that we follow. All right, so let's kind of go here. So you're doing an adjustment and correction, and you're doing it from 55. So we're saying that you have 106 degree Fahrenheit. Okay, so we're going to go back here. And we're at this table here. And again, obviously this is not a real world situation for you. I don't know why you would, you're using, well, I guess your Fahrenheit, because that's what we typically use. So right here. Okay, so you're at the 106 Fahrenheit, all right? Now you're using, in your situation, you're using 90-degree rated insulation. So you have a 0.87 multiplier, and I'm assuming you use that. So 0.87 multiplier, right? So we can go back to the ampacity now, and this is an 8, and we're using 55. I'm sure you did that. 55 times 0.87. And that is 47.85. Okay. Now, do you have an overcurrent device that corresponds to 47.85? First of all, let's see what rule tells us that we can do that. We're here. Okay. The next higher standard overcurrent device rating above the ampacity of the conductor being protected, and right now the ampacity of that conductor is what? 47.85 amps. Shall be permitted to be used provided all the following conditions are met. The conductors being protected are not part of a branch circuit supplying more than one receptacle. Doesn't sound like that for cord and plug connected loads. Doesn't sound like that's what you're doing. The ampacity of the conductor does not correspond with the standard amp rating or fuse. Okay. And the next higher standard rated selected does not exceed 800 amps. So it looks like that's what you're doing. So if that's the case, if we go to 240.6 and we look for amps, here we got a 45 and then it jumps up to 50. So as long as your load does not exceed 47.85 amps, okay, and you would need to look and see what your load is on your unit, okay, or what your water heater is putting out. If it does not exceed 47.85 amps, then that wire would be fine. Yeah, now, here's the caveat. If the manufacturer demands a certain size, let's say instead of 8, he demands 6, then you go with 6. Okay, the code's the minimum. The manufacturer can push you to another size. Okay, they just can't go lower. They can't go less than the minimum standard. But if they happen to say, and you're like, well, I want to use 8, but they say use 6 for it, in your mind, you're going to have to use 6, right? Because that's what the manufacturer dictates. And that's going to cause you problems if you do not do what the manufacturer says and something happens, your warranties or something like that. As far as the code's concerned, you're above the minimum. But if you're going to ignore the manufacturer or the manufacturer doesn't tell you, right, then in your situation, you're like, okay, I have to do what? Well, I have to make sure that I'm going to be dealing with the conductor that's going to be protected at its ampacity. That's it, okay? And so if it doesn't correspond, then you can go to the next standard side, but your load cannot exceed that value. And I'm going to assume everything with you that the lugs and everything is rated 75. We have to assume that unless you tell me other details, or we're going to assume it. Even though the amps we're talking about is under 100 amps, that type of scenario, we're going to have to assume that all the lugs are rated because you didn't say otherwise. Okay. Now, if that is not the case, then you run into a bigger scenario because even after adjustment or correction, you still can't exceed the value of the 60-degree column. Okay. So I'm going to assume in your case, since maybe you're talking a practical, real installation, that we're going to assume that everything's rated 75 for your situation. Okay. All right, I hope that answers your question. And let's see here. We'll take you back. We'll go back to ampacity real quick. Anybody got any additional questions? I'm more than happy. So at the end of the day, you're not exceeding that of the 75. Okay. And again, your conductor after adjustment or correction is only good for 47.85 amps. Okay. So you cannot exceed 47.85 amps. So I don't know what your load is. You know, we're assuming that's what your load is. Okay. So at any rate, at the end of the day, when you have a conductor that drops below it, and for this case, it was 55 and you did the ambient and you dropped down to 47.85 amps. Okay. then you have to protect that conductor at its ampacity. So again, your next size up rule's fine, but your load cannot exceed 47.85 amps. If it does, then you're going to do what? You're going to jump up to the next size. Make sense? All right, folks, appreciate you joining me today. We'll catch you on the next coffee hour. And who knows what the topic will be. Hopefully everybody has a great weekend. And we will catch you next week and catch you Monday morning. Till next time, folks, stay safe. God bless and have a great weekend.